Hi, welcome back to video number 14 in this series. Today we're going to be doing lead code number 155, minimum stack. This is basically a design question that requires us to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So I guess we are all very familiar with the concept of a min stack class, and the functions that we're supposed to implement are as follows. We need a min stack. We need to push a value. Okay. In this case, value is just a number between a huge range, right? And then we have push, pop, right? Top. Here, top, we need to get the top element of the stack. And here, the most interesting thing here is to get a minimum, which is to retrieve the minimum element in this stack, right? And here the question states that we need to implement the solution with O1 time complexity, right? Okay, so without further ado, let's just start this question. So I guess we have this particular example: min stack, push, get min, pop, top, get min. Okay, so initialize, and then so we're given an array of array, and then this is the values, right? -2, push 0, and push -3. And then once we have get min, it will be empty, right? Pop will be empty, top as well as empty, and get min. So these are only when there are values will we have values, right? And basically we're just looking for all these corresponding output values. So the only time where something is actually outputted from this, as you can see, pop here returns none, push returns none. The only time that we are returning a value is from top and get min, right? So given an array, right, yeah, let's just use this as an example. So yeah, let's just start this and like that, and then let's just indent this to base level, right? And then we have, let's say, this min stack -2, 0, -3, right? We push on, right, to the stack, the top of the stack. So we start off with -2, we push 0, and we push -3. And yeah, in this case, what we want to do, top, right, should return -3. Top element of the stack -3. Yep. And then pop in this case would also return -3, whereas top will not pop the element. Pop will remove the element, right, and return it. No, pop will not return the element. Okay, pop will not return the element. So in this case, we are given -2, 0, -3, and then we get minimum, right? In this case, get minimum will be -3, so -3 is returned, right? And then push -2, push 0, push get minimum is -3, and then when you pop something, it is a void value, so you pop it and nothing happens. In this case, when you pop, -3 should be out, right? And then when you get top, you should get 0. Yep. And then when you get minimum here, the key here is to get -2, right? So the challenge here is how we can maintain, right? How can we keep track of the minimum value while maintaining a stack property, right? So this is the key challenge, and since I'm familiar with this question, I believe what we're supposed to do here is we can actually use two stacks, right? So we can use two stacks. In this case, we have one stack called stack, right? And then we just initialize it like that, and then we have a min stack. In this case, min stack would simply be something to keep track of the minimum value at a certain level, right? So let's say this particular array, right? This is level 0, this is level 1, and this is level 2, right? And then we have stack, and then we have level. Of course, level is not going to be implemented. We just need it for reference purposes for us to understand, right? And then so we have, in this case, min stack, right? Min stack, let's just put it like that so it's easier to understand. So we have min stack that is -2. When we implemented this, the minimum value here is -2. And when we append 0, the minimum value here is still -2. And then when we append -3, the min value here is -3. And then when we kind of like we pop this value has to go off as well. So the minimum here will always be recorded as -2. Yeah. So that's pretty straightforward. Yep. And then without further ado, I think we can actually implement this. I guess top. Use a Python list as in a data structure. Use append and pop, right? Operations. Okay. Yep. Without further ado, let's dive straight into implementation. So the constructor for this would be pretty straightforward. We need to initialize two variables here. So self dot stack equals to an empty list. Self dot min stack is also an empty list, right? And then here, when we have push, what we want to do here is just simply pushing something to self.stack, right? Then we have this, and then we just append the value here, and that's more or less about it, right? Do we have to do another thing? So we have to do min stack, right? And then min stack here will have to be to append the value, right? Min stack will have to be the smaller value, right? The smaller value between the current value, right? So append the smaller of val and the previous stack value. So what we want to do here is straight away just self dot min stack dot append. Let's just add this, right? We want to do append val to be minimum of val and previous value. How do you get the previous value here? Is basically the get minimum, no, top, no. Oh, we have this, right? We have the min stack here. So what we want to do is we want to have okay, let's just start by implementing these other values first. Self.stack.pop, self.min stack.pop. This is pretty straightforward, right? The top here would just simply return stack. In Python, I believe this is the last value here, top value, right? And then the get minimum value would be to return the min stack of -1, again the smallest value here. And then since here we have pop self, we want to look at I believe we can just do this min stack 1, right? Min stack -1, the minimum of these two values, append val, and then we have this, and then we do this, right? Oops. Let me just. Yep. Okay. And I believe this is more or less how we can implement this. Pop top and get min operations will always be called on non-empty stacks. Oh yes, you need to think about empty stacks. Yeah, this is no issue. Yeah, I should have thought of this. This is no issue. So top non-empty stacks. Okay, this is non-empty. So this is fine as well. Get min fine as well. -1 fine as well. What happens when you call -1 on an empty stack, on an empty array? Probably return none. So I believe here, this is the problem here. We have to make sure that we push, right? And then we have this. And we can append this. Yeah, let's just do a check here, right? Yep, I believe this is it. Let's run it. Length of small min stack. Oh, damn it. Apologies for this. Let's just add this. If and that will be all for this question. Thank you for watching, and I'll see you in the next video.